Okay, hello. Do you hear me actually? Is it fine?
Yes, we can hear you. We can see your slides.
Okay. Yeah. Great. Okay, so welcome to my session. My name is Tomasz Juranek. I'm Sitecore MVP and solution architect from SoftServe. Yeah. Before I will start, I want to apologize you for my voice because I was vaccinated yesterday and I feel terrible. So yeah, I hope that you will get something from this presentation anyway. Okay, so today I want to talk about our experience with implementing Sitecore JSS in a large-scale project, and what do I mean about by the large scale? So in our case, it was a solution with hundreds of multi-language pages. We use Sitecore forms. We have a personalization both based on the current event in the session and based on the behavior of the visitor. Yeah, we have member accounts. We have some e-commerce capabilities. We have integration with third-party APIs, and in the end, yeah, this website is visited by millions of visitors every month. And I wanted to mention this at the beginning because some of the tips which I will give it to you today may not be applicable for some smaller project. It may be overkill if you just implement, for example, a corporate website which is just content driven. Yeah, so some of the tips will not make sense. Okay, and why we use JSS in general. Yeah. So with JSS, we can deliver a better and faster website because of the modern front-end tools and techniques which are in JSS. But JSS is not a silver bullet. Yeah? You can make a JSS site to be slow. Yeah, because yeah, if you just take a look on the architecture of JSS, yeah, where you have instead of one server which renders the page, you have at least two in the bigger scale. So there, just by this, there is some additional complexity. Yeah, and yeah, just one additional note in this presentation, there I will not talk about static site generation. Yeah, unfortunately. Yeah, it's mainly because we are not there. Yeah, we started with React implementation, and we continue with React, and with we don't have the knowledge for the Next.js so far. Okay, and why we also use JSS? Probably, maybe not probably, but in your organization you may have the same problem as we have. So we have our roles in the company are very specialized. So we have front-end developers, and when the front-end developer hears that they need to work with Sitecore, there is always a big no. And we have a backend developers which do not want to touch HTML, do not want to write CSS and JavaScript. Yeah. But fortunately, I think it changed slowly. So more and more people want to become full stack developers. But yeah, in our company, we are still not there. Yeah, so we have it divided. Yeah, and what are the problems with the traditional Sitecore development? Yeah, so without the full stack developers, there is usually this flow that you have first the front-end team implement a static version of the website based on some mockups or designs. Then there is another iteration. So the backend developers takes the static HTML and split it into MVC components with the logic to integrate with Sitecore to read the data from the fields. But this approach has, I think, a huge drawback that the backend developers need to wait for the front-end to implement those static components. And later, when there is an issue with the front-end code, who is responsible for this to solve this issue? Front-end developers don't want to work with the HTML files. They just don't want to install Visual Studio. And backend developers, sometimes they don't have the skills to write a good front-end. And I think that JSS was invented to address this problem. And how do we implement the application with JSS? So we have two development modes. One is called code first, which basically in this mode you have just the front-end team who delivers the JSS application. It can be written in React, Angular, Vue, or Next, and all the Sitecore items are also part of this front-end solution. So it's all the items are defined in YAML file. But actually, I don't see any non-testing scenario where this code first approach is better than Sitecore first. If you have a bigger website, it always will be faster just to click inside Sitecore to define the templates, to define the renderings, and sync them with the TDS Unicore or Sitecore synchronization. So in our case, it was from the beginning, we knew that we will go with Sitecore first. But with the Sitecore first, there is an issue. So this time, frontend needs to wait for the backend. And so because the backend needs to build the templates, build the rendering, define the contracts. So frontend will have data to implement the components. So how we address this issue? So we actually introduced our, let's say, internal approach, which we called contract first with Storybook. And this approach actually allowed to implement and test front-end components without Sitecore. So which basically addresses the issue that the front-end developers don't need to wait for the backend anymore. So to work with this approach, we need a proper tool, and this proper tool actually is a Storybook. Storybook is, I think, well known in the front-end world. So it's a tool which you can use to create stories. And what are the stories? The stories are some variants of the components which you can define the contract, you can define the data, use this data and just as a mocks, and you can create you can render your functional components using this data. And in our case, as you can see on the screen, we have, for example, we have stories for a component with different variants for mobile, for tablet, for desktop. But we also have, for example, a stories for the components with different variants based on the rendering parameters, which you can see on the right side. So, for example, we have a button component, and depending on the rendering parameters loaded from Sitecore, we can have different version of this button, yeah, like red, yellow, whatever. Yeah. And when the front-end team wants to test all those variants, they don't need to call the Sitecore and to have this data from Sitecore. They can write the stories for each of the variants. Okay, and to write the story, as I mentioned at the beginning, you need a data. Yeah? So you need a data contract. So the front-end developers will know how the contract looks like. Yeah? And also the backend developers needs to know how the contract will look like. Yeah. So in our case, we use some wiki-based documentation, like where we use Confluence basically, and we defined those contracts in the Confluence. Yeah. So for each component, we just define the contract. Yeah. That this component will have this type of rendering parameters and this type of the data source. Yeah. And of course, yeah, this is very simple example, but it may be much more complicated when you have the more complicated data source, for example, item and the children, and for example the sub-children or something even more complicated. And so this may not be the best approach for the small scale. Yeah, I think for the small scale, it's just better to, if you are solution architect or someone, you can just, for example, check all the components, and if you have those components at the beginning of the project, you can check those components and just spend 1 or 2 days just clicking all the templates inside Sitecore. Yeah, so you will just have all the templates and maybe the rendering items. Of course, without any logic. Yeah, if those components needs any custom logic, yeah, this is a job for the backend developers to implement. But you can spend some time just create those contracts inside Sitecore. Yeah? Because using the another tool for defining those contracts is maybe redundant. Yeah, so if there are some changes to the contract, yeah, you need to change it in Sitecore, and you need to keep your wiki also up to date. Okay, so when the front-end developers have this contract, they can actually use it to define the data for those stories. Yeah, and here on the right you have a very simple example. And if you're familiar with JSS, you may notice that this is just a fragment of the layout service. Yes, so this is the fragment which usually component use to render to get the data from Sitecore. Yeah? So if you are lazy, you can basically, and you have the layout service already, you can just copy and paste this JSON fragment, yeah? And paste it to your story. Yeah, and when we have this data, we can actually write the story for our functional component. Yeah? So what we do here is basically we this component. Yeah, in this case, for example, you can see that there is some sign-up banner from our components. Yes, we define some different stories. Actually, in this case, there are 3 stories. One renders this sign-up banner for mobile. One renders this sign-up banner for tablet. One renders this sign-up banner for desktop. And here, yeah, in this props, which is collapsed, yeah, it's actually these are the props from the previous slide. Yeah? So these are the data. Yeah, and when we run the storybook, it will automatically generate this slide, yeah, as it was on this previous slide, yeah, for the story. And yeah, front-end developer can test whatever variants, whatever viewport they want. Okay, and additionally, when we use Storybook, we can actually benefit from this even more. We can write a test based on the stories. Yes, so in our case, we use another component, which is called story shots, and Puppeteer, which is another tool. So we use it for the visual comparisons test. And actually how it works, it compares the visual of the component, and it will tell you if there are some changes, unwanted changes in the design. Yes, so in our case, when the front-end developer create a component, it's obligatory for them to create a story and to create a story shot. So, and they just commit this file, this generated image, to the repository. So we have our source image, and afterwards, if there are some another commits, another push to the repository, we have in our CI pipeline, we have some automated testing, running of those tests, and if there is a difference, if the story shot will find that there are some difference in the visual comparing to our source image, it will just fail this test. So the whole build will fail. And you can see on the screen actually one example of failed test. So additionally, it will show you what are the difference between the source image and the current image. So in this case, and from the source code and the current code. So in this case, you can see that the vertical alignment changed in this list. In general, the front-end developer needs to react and check: is a desired change or is it unwanted? I need to fix it. Okay, so we can go right now to some tips for the backend developers. So, what is the major responsibility for the backend developers in JSS? Yes, so it's to get data out of Sitecore. And the backend developers have few tools and few ways how we can get the data from Sitecore. The most obvious one is the layout service. So the layout service is actually an API, which is part of the JSS package, which you install on top of Sitecore. So Sitecore exposes you this API, and it basically return the entire layout of entire page with all the components inside as a JSON. So it includes also Sitecore forms. So the Sitecore forms are actually serialized to JSON as well. So all the fields which you define there will be returned as a JSON. And additionally, this layout service, you can extend it with custom content resolvers. So because there are some out-of-the-box one which returns the context item, which returns the data source item, or it returns the children of the context or data source item. But you can write your own custom content resolvers, which returns whatever you want. So you can write GraphQL queries. So in the JSS, types of GraphQL queries. One is integrated. One are called integrated, and those are basically executed on your server side. Yes, because in the Sitecore with GraphQL, you have GraphQL server, and you have GraphQL client libraries, which are part of the JSS solution for React Angular. Yeah, so you have those two types. So you can use the integrated one, which will be used as part of the layout service, or you can use the connected GraphQL queries, which you execute from your front-end application. Of course, you can still use the Sitecore dictionaries. There is an additional API for that, yeah, this dictionary service. And of course, you can create your own custom APIs, which is to return whatever you want for your front-end application. And what is very important in JSS, I think, is the information architecture. Yeah. So, and caching. Yeah, and about the information architecture. Yeah. So with the headless approach, which is part of the JSS, it forces you to think about your content structure in different way. Yeah. So accessing the items is no longer just call to the database, which is usually cached anyway, but yeah, it's something needs to be sent over the wire. Yeah, from the Sitecore to your JSS application. Yeah, so you should really focus on the content structure because if you will build a good structure, you'll avoid a lot of custom.NET code. But also, yeah, of course, you still need to think about how the content is. Is it easy for the content authors to work with it? Yes. So actually, SXA helps a lot with this, I think, yeah, because you can use, of course, you can use SXA JSS as well. I will talk about this in the later slides. And what we struggled at the beginning, and actually still we have some problems with that, is the data redundancy in the layout service. So for example, we have some scenarios that we return same big chunks of JSON for the different components which are on the same side. Yes, so you should actually try to reduce the JSON payload, which is returned in the layout service. Yeah. So to address this, you can actually create your custom APIs and return this data outside of the layout service and cache it in the JavaScript layer. I have also a slide about it with some details. And yeah, the second, I think, most important topic with the backend is the caching. So it was actually JSS was, for me, it was a good reason to recap how what caches are available in Sitecore. Yes. So first of all, we have our JSON output cache, which is basically the same as the HTML cache for the traditional Sitecore development. Yeah, so you can use the same configuration. Yeah, so for example, in SXA, you can use the same settings in your website setting. You can define the caching of on the rendering level, or you can globally, or you can define the caching on the specific rendering, yeah, for the specific page. But yeah, for this you need to check about with the personalization, yeah, because it may when you enable cache, yeah, the personalization may not work for you. So the next thing which is cached is the GraphQL, but you need to keep in mind that the GraphQL, by default, it doesn't cache the results of the query, but it caches the queries itself. So yeah, why we should cache the queries? Because they can be quite long. Yeah? So you can create a query which is, I don't know, 5,000 letters long. Yeah, so actually GraphQL, instead of sending this query again to the server, it just creates hash for this query, and it stores the query in the cache, and the key is the hash. Yeah, so for when the query is executed, yeah, the client just send the hash of the query. And if you want to cache the results of GraphQL, so for the connected queries, actually you can use code which is written in the JSS starter kit. So you can, in React starter kit, you can go to this src lib GraphQL client factory, and you can check this in-memory cache. Yeah, so basically it works this way that the result of the query are cached for this current request. Yes, so when you fetch this data again without reloading of the page, JSS will not execute this query again, but it will return this data from the cache. Yes, so it will work until you basically press F5 to reload the page. And next, yeah, of course, we have caching of files from media library, and the files are stored in the media cache folder. Yeah, you can clean up them just by removing those files, or if you are on Azure, you can go to my blog. Yeah, I wrote their custom script to actually clean this folder on Azure App Service. Then another caching level is the files from media library, and you can control it. You can control the cache control header, which is returned for the images. So if you go to the show config from Sitecore, yeah, there are two keys: the media response cacheability and max age, where you can define the caching of the media items. But also, if you are using the server-side rendering proxy with JSS, you can cache your static assets by writing a middleware in our case, yeah, it was in Express.js server. So yeah, I also mentioned about those custom APIs for the server-side rendering. So you can also cache it in the JavaScript layer. Finally, we have the Sitecore dictionaries, and in JSS, Sitecore dictionaries are actually, yeah, in JSS and React, they are fetched into places. When you are using the server-side rendering, your server-side rendering proxy will cache will call Sitecore to get all the dictionaries, and in the code provided by Sitecore for this proxy, there is in the config.js file, there is actually already written code for caching those dictionaries. And finally, you can cache the dictionaries which are used by the React application on the client side. And I will actually talk about it in details later as well. Okay, so some details. I mentioned about the personalization issue with Sitecore caching. So yeah, we actually address it with SXA as well. So in SXA, you can inherit your rendering parameters from this iCacheable template. and we did it for every component, and it allows content author to actually override the cache setting for the personal components. Yes, so by default we cache all the components on the global level for the renderings, but if some component is personalized, we just override this setting, yeah, with this. And actually we scripted this, yeah. So when content author will add a variant to the component, this flag to ignore caching is set automatically. Yeah, and when they will remove the variant of the component, the caching flag here is also removed. Yeah, I think I will share this code to automatically switch this flag on my blog later. I think maybe next month. Okay, and yeah, I mentioned about those custom APIs. Yes, so to avoid the data redundancy and to avoid the huge JSON payload returned from layout service, we actually created a custom API in Sitecore, which returned some items outside of layout service. And actually, it was pretty easy to reuse the code, which is used by the layout service itself. Yeah, of course, you just .pick and check how it works. And it was very simple actually, because what it does is basically read the item and return it, read the layout, read the renderings, and return it as a JSON. Yeah, so we do the same for our custom API. So what next? When you have this API, you need to call this API server-side rendering. In our case, it was in the Express.js server. So we cache it on Node.js server, and then we pass this cached data to our JSS application bundle, yeah, with the viewback. Viewback is actually one of the properties which are called, which are passed from the Express.js server to the application bundle. And yeah, lastly, just use cached data in your JSS application. Yeah, if you want the details how we did it, I published article on my blog. Yeah, you can just go to this link and check how it works. And yeah, one more details about the caching dictionaries fetched from Sitecore in the JSS on the client side, because this is not implemented by default when you create your application, JSS application with the starter kit. Yeah, it's basically, it missed this feature, but it's very easy to implement. Actually, what you need to do is just to add those few lines in the this i18n JS file in your JSS app bundle. Yeah, and of course you need this i18 next local storage backend to be added in the package JSON. Yes, so with this, without this, actually, when you browse the website written in Sitecore JSS, when you reload the page, every time the application will call the API for the dictionary to fetch the dictionaries from Sitecore, which is of course this is not optimal. Yeah, it doesn't make sense to call some API just to fetch this data, which is almost in every case it's very static. Yeah. So we just put this data to the browser local storage, yeah, and cache it for a few minutes or for 10 minutes or whatever. And again, you can go to my blog, yeah, to check the details how we did it. And few additional tips for you if you do your JSS application. So don't overcomplicate the backend. Yeah, because in our case, I think majority of the components, for the majority of the components, we don't need to write any code. Yeah, we just use the out-of-the-box content resolvers, or we actually also created some generic set of content resolvers to fulfill the most of the requirements from the component. And we just use them in I think almost every component. Yeah, and for few of the components where like our navigation and our footer, when it was required to get the data from multiple places, yes, which are not structured in Sitecore, like you don't have this structure, this relationship like parent child and in the content resolver, it's actually quite hard to get the items which are not structured. So we use just integrated GraphQL queries, which are quite simple. Yeah, after you of course learn how the GraphQL works. Yeah, so it wasn't actually a problem to implement them. Okay, and a few more tips. So in our case, we created one .NET project to serialize the items for majority of the components. Yes, so it really doesn't make any sense to create feature project per component, or even for the bigger functionalities, if all you need to do is just to have use some content resolver, which are serialized in some other, there are some generic ones, and the rest are the items. Yeah, so you will actually find that most of your projects are just serialized items and maybe some config file. Yeah, so it really doesn't make sense to create a .NET project for that. Yeah, so in our case, we just have one project for the for all the simple components where all the serialization is done automatically. So when we create the data source item, the template, when we create the rendering parameters, when we create the rendering definition item, everything is synchronized automatically. So basically, the only required task is to push it to the code repository. Yeah. And yeah, in our case, we have some Helix featured .NET project for more complicated components. For example, when the components have some complex logic, like they call some third-party APIs, or they need data from external system, then you need to create this logic somewhere. Yeah, so in our case, we use some custom content resolvers or some custom APIs to return this data. So we have to put it in this features project in the Helix architecture. And another one is that the class mapper is really not needed in JSS, yeah, because you don't need to create the strong type classes. Actually, we use this tool, I don't know how to pronounce it, this Leprechaun or whatever, to auto-generate the structures from the Sitecore templates. Yeah, so we have some structures with field IDs, with template IDs, and these are actually auto-generated upon the build of our solution in Visual Studio. And it's really simple with JSS to use the Helix publishing pipelines. This is some community-based project which allows you to very quickly build and deploy your Sitecore.NET solution. Yeah. So in our case, to deploy the code, we just need to build the solution in Visual Studio, and that's all. Yeah, and a few words about JSS and SXA. So out of the box, after you install both, you have this multi-site fast tenant and site setup with the item-based configuration. You have, I think, familiar content structure with and support for the local and shared data source for the content authors. So I think, yeah, these are some nice features. But with some custom implementation, what we did, I mentioned that, we inherit from this iCacheable template in our rendering parameters templates to allow the content to override cache settings. But we also implement, let's say, equivalent of SXA grid system and the column splitter. And I also, on my blog, I described how we did it. So you can just take it and read it. Okay, so let's jump to some tips for the front end. Before we will go into some tips, I want you to I want to present you how the JS works from the front end perspective. Yes, so in our case, we use React. Yes, so React works in basically two modes. It can be either the client-side rendering. So in this mode, the server returns just the JavaScript application file to the client, and the client generates the HTML from this. Yes, so but there is some negative part. When you return this to the browser, I think Google will not index it, because there won't be any data, any content in this page. So to address this issue, you can use server-side rendering in React. Yes, so in React, what you need to do is to build another project with your Node.js server. So yeah, in our case, we just use the code which is published by Sitecore on the GitHub for JSS. So yeah, there is an example how to set up such server with the Express.js. So in this case, basically the server generates the HTML from the JavaScript application, and what it does is basically render this application to string, and it returns the string to the client. But there is one with the server-side rendering. There is one more step which needs to be done. So this page returned from the client needs to be hydrated. So the hydration basically takes this HTML returned from the server-side rendering and call all the JavaScripts and attach the JavaScript client events. Yes, because it's not possible on server side because there is no document or JavaScript window or this kind of objects. So to visualize this process, I create for myself. I create this diagram which you have on the left side. Yes, so basically the flow looks like this: that when you browse a page with the JSS with the server-side rendering, or you do the full reload of the page, the browser calls this Express.js server. And here on this diagram, I put the name of the function which are called on each step. Yes, so we call this bundle render view first. Then there is some configuration, and at this step, this caching of the dictionary happens. The one which I mentioned before. Then the server calls the function from the JSS application bundle, which is called this render to string with data. And this render to string with data basically resolve the current route, so the current address from the browser, and you can add at this step, you can add the caching of your dictionaries, and you can also the connected GraphQL queries are also called at this stage, because when you use connected GraphQL queries with server-side rendering, they are called only by the server side, and there are so the browser doesn't need to call them again. And because it happens because when this render to strings, basically it resolves the route and it calls the layout service for this route. It returns all the data and it renders the HTML, and together with the HTML, the server-side rendering proxy return the entire JSON. And if you use connected GraphQL queries, it will also return the GraphQL query result with the, and it besides the HTML, in your browser on the client side, you will have all the JSON returned from the layout service. So when the your React application do this call this React DOM hydrate, it doesn't need to call Sitecore again to fetch the data. It just takes from this JSS state object. Yes. It's maybe it sounds complicated, but in the end, it's when you just check how it works, check the code. It's pretty simple. And basically this is how your application would look like if you render it with this client-side rendering. So this is your entire page. So there is just head body, which is empty. It has just this one div. And there is this, in the script, there is this JSS state, which in this case, with the client-side rendering is just null. But if you render it with the server-side rendering, instead of the, let's say, empty HTML, you will have entire HTML rendered on server side. And in this JSS state, you will have the JSON object returned from the layout service, for this hydration. And how actually JSS works, you can execute JSS in two modes. Actually, in four modes, but two are for the development, for the developer local environment. So one is the disconnected mode. So in this mode, there is no server-side rendering. It works. This is what I mentioned at the beginning. So you don't need Sitecore to work in this mode. You have all your items serialized YAML or JSON files. But we don't use this mode. Because we don't need it because we have this storybook. Then there is the connected mode. So again, the front-end developers run it locally on their machines. It starts the local node server, but it connects to the Sitecore to get the data. So Sitecore could be either on your local or it can be remote. And in this mode also there is no server-side rendering. But on the higher environment, so in production or test, JSS works in different modes. So we have integrated or headless mode. So integrated is basically for your CM server to support Experience Editor. So in this mode, the JSS application bundle is deployed to Sitecore and spawns Node.js process to render the page. But it's not recommended to use this outside of content management server. Yes, so in the production side, what it's recommended by Sitecore, yeah, it's to use this headless mode. So this is the mode with this external Node.js server, yeah, like this, like on Express.js. So in this mode, your JS application bundle is deployed to this proxy server. And yeah, those two modes integrated in headless actually renders the page using server-side rendering. Okay, and a few tips how to make your JSS website faster. So yeah, first of all, you have to check the lighthouse. Yeah, this is, I think, the most important tool to validate if how your website behaves. So we did those optimization to improve our application performance. Yes, so instead of using standard links, like the links which the user clicks and it just load another page with full server-side rendering, we use React Router. And so React Router allows you to go to different page without using server-side rendering, so without reloading the page, without requesting the entire page. Yes. So next, we use some modern media formats. Yes. So for example, if you use WebP, yeah, I think it's even more than 30% smaller than JPEG. Yeah, and there is a community tool to automatically convert your media library items to WebP, or to optimize them if you want to keep the JPEG or PNG file, which is called Pianoga. Also, yeah, you need to check the type of the fonts you use. Yeah, so for example, if you use WebOpen fonts, yeah, it's basically 40% smaller than the TrueType fonts. Then you should use the lazy loading of large media files or the components which are not visible when the user starts to when the user renders the website. Yeah, so you should just load those components when the user starts scrolling. Then we use the caching of the layout service output. Yeah, this is what I meant previously. Yeah, we add those cache headers to the static assets and media library. We cache the Sitecore dictionary item, both on server-side rendering and in the local storage for the client side. Yeah, we reduce the layout service payload for the common data, like the data, for example, in our case, which was returned in the navigation, it was always the same data for every page. And instead of returning this in every layout service request, we just move it outside of layout service and and return it with some external API and cache it. Then we use you can find some smaller equivalent of the JS of the npm package you use. Yeah. Then we also use some code splitting for the component for the JavaScript generated for the components. Yeah. So we divided it into some smaller chunks and loaded in parallel, which is faster. So a few details about using this React router instead of the standard thing. So to be honest, I'm wondering why this is not part of the JSS GitHub solution. It's just it was described on the Canvas blog how you can change all your Sitecore links or the links in the rich text fields to the React routers instead of the standard links. Yeah, and if you want to use it in your custom JavaScript code, yeah, it's very simple. You can just use the history API, yeah, and to just use this history.push to move to other pages. Yeah, so if you use the React router instead of the links, when you first time you open the page, it's rendered using the server-side rendering. But then when you switch the road, yes, so basically you just navigate to different pages, it will not do the full server-side rendering, but instead the client side will call the layout service. Yes, so it will call the layout service for the new road, and it will render this application client side. Yeah, so but it will, in this case, it will also change the title of the page, the meta description of the page, and so on. And so if you, for example, opened the developer tools in the to check what's going on the network, you will see that each for example, in this case, I browse 4 pages, and those pages was just the calls. First one was to fetch the first document using SSR. Then the next one was just calling the API from the layout service. Yeah, so this will be faster than using the SSR. Yeah, because SSR in the Node.js it's not the fastest way to render the page actually. Yeah, and I mentioned about adding the cache headers to static asset in the Express.js middleware. So it's very simple. So this is actually the code from the JSS GitHub again, and I just added this fragment to use this caching middleware. Yeah, so we cache, for example, every static file in the this static folder. Yeah. And we add this cache control header there. Few tips about when you start with the JSS. So the JSS starter kit, this is not production ready. Yeah, this is just a template to demonstrate the JSS capabilities. And so there is no caching of the dictionary on client side. For example, there is no support for multi-languages in connected GraphQL. There is no component level CSS. You need to use some we use, I think, SAS to achieve this. There is no implementation of React router, no code splitting of JS component, and it needs separate code for the server side rendering proxy. Yeah? But yeah, it's also published by Sitecore on their GitHub. So yeah, on the production, you basically need to implement those missing features if you want to use them. But in the JSS version 16, Sitecore added support for the Next.js, and actually Next.js addresses some of those issues. So in the with the Next.js, there is component support for the component level CSS. You don't need external code for the server-side rendering. This React router, or equivalent of React router, is already there implemented because this is part of this Next.js framework. Okay, and if you are backend developers and developer or front-end developer who wants to learn React.js, so this is my personal advice because this is how I learned it. So I just started from the React hooks and skipped the old way of working with React because I think the traditional way of implementing with React, for me it was very complicated actually. I didn't like how the code was structured, but with the React hooks, it's super simple. Yeah. So with the JSS SDK for the fields, you just need to learn how few basic hooks works. Yeah, like use effect, use state, use context, use ref, use callback, and you are good to go to implement Sitecore components. Yeah. So there is actually very good video with the introduction to React hooks. Yeah, I just watched this video and I understand almost everything with the hooks. Okay, and the last one, a few tips for the DevOps. So for the JSS app bundle for CI/CD, you really don't need to create different bundles for different environments. Yeah, because in both integrated and headless modes, what you need to do is to in the JSS configuration, when you work with your local development environment, in the connected mode, you always need to set this layout service host address, which is address of your site, for instance. But in the integrated mode and the headless mode, so the modes which are in the higher environments, this has to be empty, or it's actually recommended to have it empty. I will actually explain why on the next slide. And next, in the JSS, you have the Sitecore API key, but actually this Sitecore API key is not a secret because this API key is used on the browser's side when your front-end users just use JSS application, and this JSS application calls the layout service to, for example, fetch the data. Yeah, this Sitecore API key is there in the request. Yes, so but I don't see any reason why you should keep it secret, yeah, or different for different environments. Yes, so in our build pipeline, we also we create a single package for every environment. Yeah, we run the story shot with Puppeteer tests. We have also some robot framework tests executed on browser stack to check on different devices. And we use Azure DevOps. Yes, so we have the build pipeline and release pipeline. So with the release pipeline, we can use environment variables for our server-side rendering proxy, and we can actually set the Sitecore host there using the Azure app settings, which are visible in Node as environment variables. Yeah, so we are deploying our application to Azure slot. If you have a Node application running on for the server-side rendering, so when you create an Azure app service and you deploy it, you need to remember there is a checkbox there in Azure DevOps to actually create a web config for the Node.js. Without this, the Node.js will not start. Yeah, so then we do some warm-up. We call some URLs to warm up the website. Yeah, we run the Lighthouse to check what is the score. There is a plugin in Azure DevOps Marketplace to run Google Lighthouse from there. And finally, if everything is correct, we swap the slot, the staging slot with the production slot. And about this Sitecore API host configuration in the JSS app bundle. Yeah. So if you keep this parameter empty, all the calls to the layout service in the headless mode will go through the Express.js proxy. And so it will not go directly to your Sitecore CD server, but in the code of the published by Sitecore for the server-side rendering. There is in the config there is this part for the proxying. Yeah? So there are some routes which are directly proxied to the Sitecore CD. Yeah, so for example, all the calls to the layout service, all the calls to the custom APIs, the robots.txt or sitemap XML. So you just generate those files or use SXA on the Sitecore side, and when the visitors opens the page, yeah, the request will go to the JSS proxy, and this JSS proxy will directly proxy this request to Sitecore CD. Yes, so if you will additionally use this parameter to use different hosts for your media items. Yes, so for example, if you have media on CDN, in the settings in Sitecore, there is this media link server URL. You will, instead of a Sitecore CD address, you will use some like this JSS this JSS this Express.js address. You don't need to expose Sitecore CD server to the public. Yeah, because actually the Sitecore CD server will be only called by this JSS proxy. Yeah, the server-side rendering proxy. Actually. So yeah, you can just limit access to this IP address of the proxy. Yeah, but if you want to use this Sitecore API host in your config file in the JSS app bundle, you can do it. So all the calls which are done directly from React application from your JSS will go directly to Sitecore CD server. But yeah, in this case, the Sitecore CD server needs to be exposed to the internet, and it has to use the same domain as this SRR proxy to avoid the problems with cookies and the form submission and this kind of stuff. Yeah, so I think usually you shouldn't do it, but maybe you can gain some milliseconds on the performance when you will do it. Yeah, and finally, you can use environment variables in the JSS application bundle if you want. But and actually, recently, guys from Sitecore did it for the Next.js. Yeah, so you can check this pull request for the Next.js, how they did it, and you can adapt it to your React application. But there are some extra work which needs to be done. So this will work on the client side as well. So if you will do it, your configuration in the JSS will look like this. Yes, so there will be primary. If there is an environment variable like this Sitecore JSS server bundle, the code will use this, and as a fallback, it will use some default value. Okay, that's all. So thanks for having me. And if you want to contact me or check the some details, you can go to my blog. And many of the discussed today, it's described in my blog as well.
Thank you, Tomek.
Okay, thank you.
It's time for questions. So if anyone have any questions, I think you can raise your hand or something like that. It should be available somewhere in the UI of this application. Oh yeah, I think it's just better. Right. So any questions? Okay, I don't see like any questions, so maybe I will ask you for one topic. I'm not sure if I understood that correctly, but you said something about preparation of your own or custom service, which returns the JSON instead of the service layer service, right? Because the amount of JSON which is returned is significantly different. So how it happened that you decided like to prepare your own service for that, and what are the differences in when we talk about the amount of data?
Yes, so in our case, we developed actually some e-commerce based solution. Yeah, it's not Sitecore e-commerce, of course, but we have some products, yeah, which are defined as items, and those items are quite complicated. There are multiple fields. And so, and we in our navigation we have some booking widget, which basically you can use this booking widget to quickly order those products. Yeah, and this booking widget is part of the navigation, therefore is returned by on every page. Yeah, so we find out that majority of our data returned from the service, from the layout service for every page was actually those products. Yeah, so because we have, for example, a page with the media banner and with some rich text content and maybe one more component. Yeah, so it's with the JSS it's quite small, yeah, because the data is quite returned in quite optimized way. Yeah, so this is just the key values pair. Yeah. So, but if you have a complex items like we did, like we had, yeah, like this product item with, I don't know, 20 fields, yeah, or 10 fields, whatever. Yeah, we find out that the majority of our JSON payload was actually this JSON return in the navigation. Yeah, and this JSON was totally the same for every row, because you have the same booking widget displayed on every page. Yeah, therefore we decided to remove this from the layout service. Yeah, so we still return this rendering, but this rendering right now has empty data source. Yeah, so and instead of using data source, we use the custom API. And because our custom API is basically return the data in exactly same structure as the layout service did, we didn't have to rewrite our front-end component. Because yeah, we just change in Sitecore JSS on the front-end component. You either take the data from you have the props.fields or prop for the fields from the item, or props.params for the fields from your rendering parameters. Yeah. So we just had to change it the props dot I don't know, some custom something hour, and the rest was exactly the same. Yeah. Because the field names didn't change. Yeah, because we still return exact same items, exact same structure, but instead of doing it with the layout service, we do it outside of it.
Okay, thank you. Now it's clear. All right, let's see. So, any other questions, maybe?
Yeah, I just scrolled the chat to check if there is something.
Okay, I don't see any questions. Guys, to give that gift card for Pluralsight, we need someone asking questions. I cannot take it for myself. All right, we'll think what to do with it. maybe we'll just check or try to pick someone from the list of the attendees. All right, guys. So that would be it, I think, in terms of the presentation. So, Tomek, thank you very much once again for the time and the preparation and the presentation. That was really great. And well, if you have some time, then please stay with us a couple of minutes just to discuss less important topics in the tables or on the tables. Yeah. All right. Thank you once again. Take care, guys.